We're used to imagining Mars as a cold, barren planet devoid of any life-giving water and atmosphere. It's been covered with lifeless deserts seared by lethal cosmic radiation for billions of years now. Still, surface of Mars bears traces of ancient seas and rivers which were even more turbulent and water-abundant than those on Earth. And the deeper we delve into the history of the red planet, the more startling aspect it assumes. This is Mars. That's what it is believed to look like several billion years ago. Heat and liquid were trapped within the dense CO2 atmosphere. The planet was shrouded in numerous rivers used to flow on its surface, and most of its northern hemisphere used to be covered by water. However, all this was to vanish, leaving behind early traces on rocks. It is thought that the weak and unstable magnetic field of Mars failed to protect it against solar wind. In hundreds of millions of years that followed, its atmosphere gradually deteriorated, with water vapor breaking down into hydrogen and oxygen. As for oxygen, it reacted with rocks, which gradually led to the planet getting tarnished by rust, and now a thin layer of orange dust and perpetually frozen ground is all that remains. To truly comprehend Mars's current state, its thin atmosphere, its frigid surface, and its lost potential for life, we must journey deep into its interior. The secrets to its dramatic evolution are locked away here. Thanks to seismic data from missions like NASA's InSight lander, we are finally beginning to piece together this planetary puzzle. At the planet's heart lies a surprisingly large, liquid core composed primarily of iron and nickel, but with a significant amount of lighter elements like sulfur. With a radius of approximately 1,830 kilometers, this core is far less dense than once thought, a discovery that has reshaped our models of how rocky planets form. While scorching hot, estimated between 1,800 and 2,000 degrees Celsius, the Martian core lacks the crucial ingredient for a protective magnetic shield. Unlike Earth, its liquid core is not believed to be convecting vigorously enough to generate a geodynamo. This planetary engine shut down billions of years ago, leaving Mars defenseless against the harsh solar wind, which relentlessly stripped away its once thicker atmosphere. Encasing the core is a silicate mantle, roughly 1,200 kilometers thick. This is not a molten sea, but a layer of solid rock rich in olivine and pyroxene. Over geological time, this mantle has behaved like a thick, slow-moving fluid, with convection currents powerful enough to create the colossal volcanoes that dominate the Martian landscape. Finally, we reach the surface layer, a massive, ancient crust. Its thickness is highly variable, ranging from a thin 20 kilometers in some regions to a staggering 90 kilometers in others. This crust is much thicker on average than Earth's, and is composed mostly of volcanic basalt, a testament to the planet's fiery, geologically active past. Most striking is the planet's crustal dichotomy. The northern hemisphere features smooth, low-lying plains, while the southern hemisphere is a landscape of ancient, heavily cratered highlands. Scientists debate if this was caused by a single cataclysmic impact from a protoplanet, or long-term internal mantle dynamics. This mystery remains a central question in Martian geology. Decades of observation from a fleet of sophisticated orbiters have yielded hundreds of thousands of images of the surface of Mars. These instruments have peeled back the layers of the red planet's history, revealing a world far more dynamic than we imagined. And one such region of interest is Valles Marineris. This gigantic system of intertwining canyons and chasms stretches along the planet's equator for 4,500 kilometers. Dwarfing Earth's Grand Canyon, it wasn't carved by a river, but was ripped open by immense tectonic forces linked to the nearby Tharsis volcanic region. It is here, at the westernmost edge of this colossal scar, that the unique and mysterious region marked on maps as Noctis Labyrinthus, or the Labyrinth of Night, is located. Its name perfectly captures the bewildering, maze-like terrain. Here, numerous deep, steep-edged rifts intersect multiple times, dividing the surface of the planet into regularly shaped blocks. This intense faulting created a chaotic landscape of isolated mesas and deep troughs known as grabens. Over billions of years, the slopes of the chasms have collapsed in many places, leaving behind numerous landslides. The sheer scale of these collapses, likely triggered by ancient Marsquakes, created some of the largest landslide deposits seen anywhere in the solar system. Evidence of this can be seen in the traces of deep water erosion seen at the bottom of most chasms and in the layered structure of slopes and landslides. These layers contain clay minerals and sulfates, which only form in the presence of water. Observations show that Noctis Labyrinthus is periodically obscured by dense fog. This fog is composed of water ice crystals, meaning that it is still one of the most humid regions on the planet, hinting at ice hidden just beneath the surface. As one moves eastward, the bizarre interlocking chasms of Noctis labyrinthus gradually morph into a system of giant canyons that occasionally intersect. It is here that the deepest point of the Valles Marineris is recorded. It lies 11 kilometers below the surrounding plateaus. Calculations show that in ancient times Kopretis Chasma was a narrow and long-running water lake which, when it was fullest, was comparable in volume to Earth's Black Sea. As we continue along the canyon, we find that it gradually loses its steepness and gently dissolves into the giant Chrysi Planitia. Similar geological formations can be found on our planet in the deltas of major rivers such as the Amazon and the Nile. To get a closer look at the Red Planet, we travel far to the east. After flying several thousand kilometers over unfriendly rocky deserts, we reach a large crater called Gale. This location wasn't chosen by chance. Scientists selected it for the towering mountain at its center, Mount Sharp, whose exposed layers of rock offer a geological record of Mars's ancient history. About 3.8 billion years ago, a massive asteroid collapsed here, leaving a deep circular depression 154 kilometers across. For millions of years, this basin was filled with sediments carried by wind and water, which were later sculpted by erosion into the 5.5-kilometer-high mountain we see today. The story of this mission began on August 6, 2012, when the Curiosity probe landed on Mars. The landing was an unprecedented feat of engineering, a sequence dubbed the 7 Minutes of Terror. The car-sized rover was lowered to the surface by a rocket-powered sky crane. Almost immediately after landing, the rover found evidence that the planet used to be much wetter. It discovered an ancient stream bed with smooth, rounded pebbles, clear proof that a persistent stream once flowed here. Curiosity then headed east to a sandpit called Rock Nest. Here it took its first soil sample and found it contained around 2% water by weight, chemically bound within the minerals, a vital discovery for future explorers. As the rover climbed, the sand and silica under its wheels gave way to hematite, an iron oxide that only forms in contact with liquid water. This confirmed that Gale Crater once hosted a persistent aqueous environment, one that could have supported life. Here, Hellas Planitia is one of the largest impact craters on Mars. It is thought that about 4 billion years ago, a massive asteroid with a radius of about 50 kilometers crashed into the planet here at high speed. The terrific explosion left behind a gigantic crater about 2,300 kilometers in size, a truly colossal scar, and millions of tons of rock were crushed and ejected far beyond its limits. The giant lowland area that appeared at the impact site was quickly filled with water, forming a large lake or a drainless inland sea. During Martian winter, the Hellas Planitia is entirely covered with frost and, when seen from Earth, appears as a large bright spot. Next, our route takes us to the north, to Jezero Crater, which used to be a large running water lake in the past. It was one of these regions that became the priority target of the Perseverance rover, which descended into Jezero Crater on the 18th of February, 2021. It was at this point that the unique Ingenuity helicopter got to show its worth. It flew over the surface of the planet and provided a wide-angle panorama of the ancient delta. Eventually, after a long and arduous journey, the rover did reach the delta and began exploring it. In addition to desert landscapes and rocky debris, Perseverance occasionally photographs the night sky of Mars. For example, this little white dot here is one of its satellites, Deimos. More recently, Perseverance captured Phobos briefly eclipsing the Sun. This unique observation was not just a spectacular sight but also provided astronomers with a wealth of important data. Unlike our planet, Mars has 2 satellites which are very small, irregularly shaped celestial bodies. Due to tidal forces, Phobos is gradually losing height, about 1.8 meters per century. It is estimated that in 11 million years, it will be crushed by the pull of Mars into many fragments. Deimos is a very dark object because its surface absorbs almost 93% of the light shed on it. The satellite's small size means that its disk cannot be seen from Mars with the naked eye. When you look at Mars, frozen in its immutability, it is hard to believe that once upon a time turbulent rivers would run across its surface, their force by far greater than that of rivers on Earth. The expanses of the Red Planet are full of riddles and surprises, and most of them remain to be uncovered yet. And although it may appear that Mars has long been in its autumn years by now, human tenacity and thirst for knowledge may supply another page in its history yet. Everyone has a chance to contribute to this process by participating in space exploration or just liking this video. Let's keep in touch.